In this video, we'll cover differential equations and separation of variables. Separation of variables is a special method to solve some differential equations. A differential equation is just an equation that has a derivative in it. This method is only possible if we can write the differential equation in this form, where I have by dy equal to ax dx. We call this separation of variables because we need to move all of the x's, including dx, to one side of the equation, and all the y's, including dy, to the other side of the equation. Our first problem asks us to find the general solution of dy dx equals to 3x squared e to the negative y, and the particular solution whose initial condition is y of 0 is equal to 1. Alright, so I'm going to go ahead and just start by listing our steps. So first thing, I'm going to go ahead and multiply both sides of the equation by the dx and divide both sides by e to the negative y. So I end up with 1 over e to the negative y dy equal to 3x squared dx. In my next step, I'm going to go ahead and move that e to the y to the numerator. Okay, so I can see that all of my x's are on one side and all my y's are on the other side. That's good. So we need to separate, then integrate. So in step 3, I'm going to find the integral of both sides. And this is just an indefinite integral, so we will need to add on a plus c. Now, we can add a constant to both sides, and that would be totally right, but we're going to be combining our constants together, so it makes more sense just to add a constant to the right side of the equation. All right, so the antiderivative of e to the y is just e to the y, and on the right side, this will give me 3x cubed over 3 and plus c. I'm going to clean up just a little bit. All right, so now I can go ahead and substitute in my initial condition, y of 0 is equal to 1. So in step 6, let's see, my y is 1, so this is just e to the 1 is equal to 0 cubed plus c. So I can see that my e is equal to c. Now that I figured out what my e value is, let's go ahead and make the substitution back into this equation here, and then we'll solve for y. All right, so I've got e to the y is equal to x cubed plus e, and now we solve for y. So I'll take the natural log, oops, I just want to use parentheses there. And let's see, this is going to give me y is equal to the natural log of x cubed plus e. And that's my final answer. Here's another example. All right, so we're going to separate, then integrate. So first step, if I multiply both sides by y squared and multiply both sides by dx, I'm going to have y squared dy is equal to x dx. That's separate. Second step, integrate. Y cubed over 3 is equal to x squared over 2 plus c. Now, I need to solve for my c, so I'll substitute in my initial condition, y of 0 is equal to 1. So I'm going to have 1 over 3 is equal to, well, 0 plus c. So my c value is equal to 1/3. I take this c and I'm going to substitute it back in right here and then solve for y. Okay, so let's see. I guess we'll call this step 5. In step 6, I'll multiply everything through by 3, so I'll have y cubed is equal to 3x squared over 2 plus 1, and then I'll take the cube root. Okay, this is my solution. Solve for y. So separate, then integrate, find your c by substituting in your initial condition, and then solve for y. All right, here's another one to try. So again, all right, so in this one, our x and the y are both in the exponent of this exponential. So I'm going to have to, first thing, rewrite this a little bit. So dy dx is equal to e to the 2x times e to the y. Remember, when you have the same bases, you add your exponents, and that's what the result is here. So I'm just kind of separating this out. Okay, so now I'll move my, separate my terms. So I'm going to divide by e to the y, so that's 1 over e to the y. Okay, so then I need to integrate. And what I notice here is that I've got a u substitution going on because I have this 1 over e to the y. In fact, I'm going to go ahead and rewrite this a little bit, e to the negative y. So my function within the function is right there in the exponent. And I've got another u substitution on the right side. 2x is the u in my the function on the right. So let's do a little bit of u substitution. So u is going to equal to negative y. So du dy is going to be negative 1. So dy is going to equal negative du. All right, on the right side, u is equal to 2x. Du dx is equal to 2, and dx is equal to, I believe that's 1/2 du. All right, so now we'll make some substitutions. So I'm going to go ahead and call this step 4, even though we did quite a bit of work over there. Let's see, I've got the integral of e to the u, and then times dy, which is negative du. So I'm going to write it like this. And this is equal to, let's see, I'm going to bring the 1/2 out front, integral of e to the u dx. Oh, du, sorry. I knew that was weird. They both have to have u's. All right, so now the antiderivative of each of these, well, is just e to the u, right? And so this is going to give me negative e to the u, and I'll go ahead and substitute in what u is equal to, which is negative y, is equal to 1/2 e to the u plus c. And I'll just double check, make sure I've got all this right. Yep. All right, so at this point, I'm going to substitute in my initial condition. This time is 0, 0. So I'll call this step 5, change it up a little bit. So this is negative e to the 0 is equal to 1/2 e to the 0 plus c. So in step 6, I can see this is negative 1 equals e to the 0 is 1/2 plus c. If I subtract 1/2, c is going to give me negative 3/2. All right, so in step 7, I'm going to substitute that back in right here. So I've got negative e to the negative y equals 1/2 e to the 2x minus 3/2. Now all I have to do is solve for y. Okay, so let's see. I'm going to erase this over here, and I'm going to change to a bright blue so we make sure we're following. First thing I'm going to do is get rid of that negative sign. So in step 8, I'm going to have e to the negative y equal to negative 1/2 e to the 2x plus 3/2. And then I'm going to take the natural log on both sides. So step 9, natural log e to the negative y equals natural log negative 1/2 e to the 2x plus 3/2. And this is going to give me in step 10 the negative y equal to all of this. And my last step, step 11, get rid of the negative. And so I'm going to have y is equal to negative ln. And I believe that is the final answer. A lot more algebra manipulation. Okay, in the next problem it says find the general solution of this guy and the particular solution whose initial condition is 0, 2. Okay, let's do it. Separate, then integrate. So what do we see here is that we've got x's on both sides. That's not going to worry me too much. We can handle the algebra. All right, so let's see. I'm going to multiply both sides by dx. And, well, let me go ahead and start. 1 plus my first step is to go ahead and move that xy to the right. And then I can divide. Okay, so now I can see my process here. I'm going to divide by y, and I will leave the x there and divide by the 1 plus x squared and multiply by the dx. So I think I've separated them. Just make sure. Yeah, looks good. All right, so now separate, then integrate. So in step 3, let's integrate 1 over y dy, integral of negative x. And this looks a little complicated because I think I have a u substitution here. So I'm going to let this side is going to be easy, natural log y. This side, I'm going to say my u is equal to 1 plus x squared, so du dx is equal to 2x. And this is good because it'll cancel the x in the numerator. All right, and so dx is equal to, well, let's see, if I multiply both sides, 1 over 2x du. That's my u substitution. All right, so now step 4. I'm going to have natural log y on the left equals, and I'm going to end up with the integral of negative x over u times 1/2 1 over 2x du. And see how my x's will cancel. I can bring the negative half to the front, and I have 1 over u, and that'll give me natural log. So that wasn't too bad. All right, so in step 5, natural log. Natural log of u, my u value is 1 plus x squared plus c. All right, so now I've integrated. Now I can substitute in my initial condition, 0, 2. So in step 7, I'll go ahead and change the color because I'm kind of moving on to the next step here. And I probably need to stay in numeric order. So this will give me natural log 2, which is just a number, equals 1/2 natural log. The x is 0, so this is just going to be natural log of 1 plus c. And all of this guy, e to the 0 is 1. 0 times 1/2 is just 0. So this is just natural log 2 is equal to c. So that made that easy. And the next step, I'll go ahead and substitute that in for c. So in step 8, natural log y all right, and then we just need to isolate the y. And so I can undo the natural log with exponentiating. So in steps 9, if I exponentiate both sides of my equation, I'm going to have y equal to e to the negative 1/2 natural log 1 plus x squared plus natural log 2. So I want to show you something. Let me see. Can I do that here? Yeah, so right here, this side of the equation, I can write that instead as e to the negative 1/2 ln 1 plus x squared times e to the ln 2. Now the reason I separated that out, and I can do that because I'm adding these two terms in the exponent, because e to the ln those are inverses, and so all of this is equal to 2. So I can have this absolute value of y is equal to, well, 2e to the negative 1/2 ln 1 plus x squared. That's it. There we go. Cleans it up quite a bit. Now, we have the absolute value bars. We need to get rid of those. And we can do that by writing our equation with a plus or minus sign. So in step 10, I know, y'all are thinking this is never ending. Plus or minus 2e to the, but they are kind of fun. Sorry, there we go. And then now the last step is to decide, do we need the plus or do we need the minus? And that's based on the initial condition. So our y value was 2. So we know that if we substitute in a 2 for this y here, and then we substitute in a 0 for the x, I need to have a positive 2 here. And so if I'm going to have a positive 2 here, let's see, if I plug in a 0 here, that's going to give me, I'm just doing some little scratch work on the side, 2e to the negative half ln 1. Well, we already said e to the 0 is 1. And so this is just going to equal 2 times 1. Well, if we want it to equal 2, then this needs to just have a positive sign, a plus sign on it. And so our final answer is going to be y is equal to 2e to the negative half ln 1 plus x squared. Okay. Here's another one that I've worked through, and just to save some time, I'm just going to explain it. So separated the variables, integrate. I've got a u subs on the left. My u is 3 minus y. The derivative is -1, so dy is negative du. That gives us natural log when we integrate. Sub back in the u value, add the plus c on the right, and the antiderivative of 6, of course, is 6x. Oh, what happened to... Oh, what I did here, I didn't show my step, but I plugged in my initial condition, 1, 1. And so 3 minus 1 is 2. 6 times 1 is just 6. Okay, sorry about that. And then we're getting the c by itself, so I subtract the 6. So there's my c value. All right, so I plug my c value in to right here. And then I'm going to divide both sides by the negative to get rid of it on the left, and then exponentiate both sides. And then here is, again, that same property where we're adding these terms, and I'm adding, and what I can do is I can just rearrange these, since this is just addition is commutative. Move that 6 with the 6x, and then the ln 2 by itself, and because I'm adding these terms, I can multiply here, and then this will give me 2. Because e and ln are inverses, the 2 will come to the front. So then we're isolating the y, so we subtract 3, divide by a negative, and then we have to decide, do we need the plus or the minus? Well, in this case, with our initial condition 1, 1, we want the y to be 1. 3 minus 2 will give us that 1 value, and so we just leave the minus sign. All right, so here's an AP question. I think it's from the 2014 test. It says, consider the differential equation. Let y equals f of x be a particular solution with initial condition f of 0 is 1. The function f is defined for all real numbers. Write an equation for the line tangent to the solution at point 1, 0. All right, so we have a point. We just need the slope. So dy dx evaluated at this point 1, 0. Let's plug it in. So I'm going to have 3 minus 1 cosine of 0. So this is going to give us 2 times cosine of 0 is 1, and so this is just 2. So we know the slope is 2. So my tangent line is going to be y minus 1 is equal to m x minus 0. Or y is equal to 2x plus 1. Now let's evaluate point 2. 2 times 0.2 plus 1, and 2 times 2 tenths plus 1, 4 tenths plus 10 tenths is equal to 14 tenths, which equals to 1.4. Okay, so in part C it says find y equals f of x, the particular solution to the differential equation with the same initial condition. And so this is just using our separation of variables. So let's see. I'm going to go ahead and move my y over. So divide both sides by the 3 minus y. And I can see that I'm going to have a u sub on the left. And then this is going to equal to cosine x dx. It'll be easy on the right. Okay, so I separated. Now we integrate. My u is going to be 3 minus y du dy, -1. So dy is equal to negative du. Okay, so I have the integral of 1 over u times du equal to the integral of cosine x dx. Okay, so let's see, this is going to give me natural log the u, and my u is going to be 3 minus y is equal to sine x plus c. And I've got my initial condition 0, 1, so this is going to be natural log of 3 minus 1 equals to sine of 0 plus c. Okay, so then I end up with that c is equal to negative natural log of 2. And I don't need those bars anymore because 2 is just a positive number. So that's nice. We're going to go ahead and substitute that back in. So I have, let me change my color so I know I'm kind of like moving on to the next step. So negative ln 3 minus y is equal to sine x minus natural log 2. And then divide everything by a negative, so natural log 3 minus y is negative sine x plus natural log 2. Exponentiate, and again, that same quality that we saw, our property of exponents in the last two examples, we're going to see again. So this is 3 minus y is equal to, right here is what I'm talking about. I have e to the negative sine x times e to the natural log 2. So 2 and then e to the negative sine x. Get rid of the absolute value bars. By adding the plus or minus on the right. Subtract 3. And I'm going to just jump to another color so I keep organized. So negative y is equal to negative 3 plus or minus 2 e to the negative sine 2x. Sorry, a little crowded over there. And this is going to give me y is equal to 3 plus or minus 2 e to the negative sine 2x. Okay, so is it going to be plus or minus? Well, I need to go back to my initial condition. If my y value is 1, here, I need to get this guy to equal 1. Well, then 3 has to subtract 2. And so that's why I know that it's going to be a minus sign in my final answer. So let me get rid of all that. And my final is going to be y is equal to 3 minus 2 e to the negative sine 2x. And that's it. Okay. I don't know why I ended up writing a sine 2x. It should have just been sine x. Sorry about that, guys. I just realized. I was like, where did this extra 2 come from? That should have just been sine x. So if any of y'all caught that, good for you. I'm just writing extra 2's. Didn't mean to. There we go. All fixed. Okay, here's another free response from a released AP test. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At a time of 0, when the bird is first weighed, its weight is 20 grams. Okay, that might be important. In fact, you know what that is? That's its initial condition. There we go. So dB dt is equal to 1/5 100 minus b. So let y equals b of t be the solution to the differential equation above with initial condition 0, 20. Hey, and there it is. So, question A, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? And explain. So, let's just calculate. So, dB dt at 40, and then dB dt, what's the rate of change at 70? So, let's plug it in. 1/5, and then 100 minus 40. So 100 minus 40 is 60. A fifth of 60 is 12. So the rate of change when it weighs 40 is 12 grams per day. When it weighs 70, oops, 1/5 of 30 is 6. So we can say the bird is gaining weight faster when it weighs 40 grams because dB dt at 40 is equal to 12 grams per day. dB dt at 70 is equal to 6 grams per day. Okay, so this last problem, it says is to find d squared b. So we want to find the second derivative in terms of the first. And so if this is our first derivative, let me go ahead before my pen runs out, distribute the 1/5, so that's 20 minus 1/5 b. And so d squared b over dt squared is equal to negative 1/5 dB dt. Okay? And so we can't leave a differential equation in terms of a derivative, so I need to substitute in what dB is. So d squared b over dt squared is equal to negative 1/5 times, 1/5 minus b. So how about just 20 minus 1/5 b? So then this is equal to negative 4 plus, what is this, 1/25 b? All right, so we need to find our critical value, so we're going to set that equal to 0, and negative 4 plus 1/25 b equals 0. Add 4, so 1/25 b is equal to 4 multiplied by 100, so b, 25, so we get 100. So b is 100. That's our critical value. All right, so 100. Let's pick a number to the left of 100. And we're looking at between 0 and 100, or I'm sorry, 20 and 100. So we'll pick a number between 20 and 100. If I pick 50 and I plug it into this equation, that's going to give me a negative value. That's important because what we're trying to look at is, it says find the second derivative in terms of b, use the second derivative to explain why the graph cannot resemble. The second derivative is concavity, right? And so we've just said between 20 and 100, we should be concave down. If I look at this graph here, this is concave up. And so that's why it cannot be the graph. Okay, and so I think there was one more problem, and the last one is just use separation of variables to find the equation with the initial condition. And we have certainly practiced quite a few. If you want to continue to work, and if you have questions, please let me know. But I will show you on the last page. Here's the solution. And so take a snapshot, work through it, and let me know if you have any questions.